SMR stands for small modular reactors. That refers to the fact that in general, they will be smaller than the traditional nuclear plants that have been built, roughly 300 megawatts in size, as opposed to the 600 to 1100 megawatts of current large reactors. They're being marketed as small, but they're not really all that small, especially if, as the industry plans, they're going to bundle them in groups of 2 or 4 or even 8. So when you get up to 8 of these SMRs at the same site, they're pretty big, about the same as current large reactors. There are roughly 80 different proposals for SMRs being considered or proposed or marketed around the world. So it's hard to qualify all of them as being small. I tend to think that the word small is being used because it's less threatening to the public. There are 3 SMRs currently operating worldwide, 2 in Russia and 1 in China. There's a 4th under construction in Argentina. But what all of these projects have in common is that their costs have been significantly higher than originally forecast. As you can see, if you look at figure 1 from our report. Proponents say that because SMRs will be mass produced in factories and assembled on site, they will be less expensive than the existing large reactors in the world today and will be built in significantly less time. However, the recently completed Vogtle reactors in Georgia used modular construction. Nevertheless, their actual cost, somewhere above $36 billion, was more than $22 billion higher than the initial cost, in spite of the fact that it used modular construction. A number of the vendors of SMRs have announced significant cost increases over the last year or 2. Generally, there are 3 reasons for this. First, rising cost of labor and construction commodities, the steel, the concrete, et cetera, that go into building reactors. The second reason is higher interest rates, so the cost of financing the projects is higher. And the third is there are design changes over time. None of these SMRs is fully designed and licensed, so we can expect that there will continue to be design changes in the future. Proponents claim that as more SMRs of a single design are built, the cost will go down, but there's no evidence of that. It's called a positive learning curve, meaning that lessons learned from building the early reactors will lead to cost savings in the future. That has not ever worked for the US nuclear industry. In fact, the industry in other countries as well. And there's no reason to believe it will happen with SMRs. Quite simply, the higher the cost of building a new reactor, the higher the cost of power will be from the project. Most of the cost of the energy from a nuclear power plant is tied up with its construction cost. So it's a pretty direct relationship. The higher the construction cost, the higher the cost of power. Ultimately, we believe that SMRs, in order to be deployed around the country at scale, that the federal government and taxpayers will have to pay all or a large percentage of the cost of building the SMRs. And we're talking about the scale of trillions of dollars for the several hundred SMRs that the industry is talking about building over the next decades. Another option is that taxpayers would have to pay for big tax incentives for the developers. One plan the federal government has floated is what they're calling cost overrun insurance, which really just means that taxpayers will pay for the cost overruns at new reactors, including SMRs.